and we have a light bulb right here. And you can see that the light for the light bulb, there are two terminals. We have one terminal at the side and one terminal at the bottom. So this is the light bulb and it has two terminals.
Today we will continue our study on electricity and magnetic field. The first activity of the day is to identify circuit elements. On your table you will find a lot of circuit elements, measuring instruments and so on. The first thing is you will identify them, you will characterize them, and you will describe ways of measuring these circuit elements. The second activity is about constructing a current tester. Now you proceed to identify circuit elements and characterize. Here you go.
In front of us, we have different objects used in electrical systems. So we are going to identify and fill out this table. So first I'm going to identify each element, and you are going to describe each parameter so that we can fill the table with it.
Then I'm going to fill out the circuit symbols of every circuit element. And as a circuit symbol is a conventional symbol, we used to represent the materials we've been given in a circuit while sketching it on paper.
And I can explain the characterizing quantity of the circuit elements.
And I'll describe the measurement of the circuit element and list the physical quantities that are used to measure the characterizing quantity.
So, and there's also the number of terminals, and I'll try to include that in my saying. So let's start. The first thing in our table is the resistor, and the resistor is this one. And there are also multiple kinds of resistors, just like this one. And resistors impede impede current flow in the circuit, and you can see that there are two terminals of the resistor. So what's the circuit symbol for a resistor?
I can draw a circuit symbol for a resistor. For every resistor, we have a circuit symbol of something that looks like a zigzag extended by two lines, like that.
So what's the characterizing quantity?
Resistance.
Okay, resistance.
And we can measure resistance using ohms law, which is voltage over current.
And it has also two terminals, and we can measure the resistance of a resistor by using the color coding on the resistors. So the next is the light bulb, and we have a light bulb right here, and we can see that the light for the light bulb, there are two terminals. We have one terminal at the side and one terminal at the bottom. So this is the light bulb, and it has two terminals. So what is the circuit symbol for a light bulb?
The circuit symbol for a light bulb is we draw a circle first, then inside the circle we draw an X, and we draw two lines coming out of the circle.
Okay, it's a characterizing quantity?
Power.
Okay. I think it also characterizes the resistance and voltage.
And the method of measurement?
Yeah, we can measure the power using the formula voltage times current. So P is equal to V times.
Okay, and it also has two terminals. So the light bulb has two terminals. And the third one is a dry cell. And we have multiple dry cells right here. And these are the dry cells. And you can see that the dry cell has two terminals, one negative and one positive terminal. And the dry cell is the source of voltage in our electrical systems. So what is the circuit symbol for a dry cell?
The circuit symbol for a dry cell is that we draw two parallel lines, one shorter and one longer, and we also have two lines coming out of those lines.
What is the characterizing quantity?
Well, the characterizing quantity is voltage, and as we can see, it has 1.5 voltage written on it right here, but the voltage we receive at home is 220 volts, and our cell phones also have 20 volts within them.
And what is the method of measurement for a dry cell?
I think we can measure voltage by directly applying Ohm's law. So voltage becomes resistance times current.
But I don't think so. I don't think we can characterize or measure the voltage of a dry cell. Rather, it can be measured by a voltmeter. Would you think so? This? Yes, I think so. Yes. Okay, so we have also seen that the number of terminals for dry cell are two, one negative terminal and one positive terminal. So let us go to the fourth one, the switch. So yes, we have a switch right here. And you can see right here that this is a switch that we can use on our circuit board. And what the switch does is make it easier for us to close or open the circuit and allow current to flow or stop current to flow throughout our circuit. So what is the circuit symbol for our switch?
It looks like this. This is to represent the opening and the closing of the switch.
So what is the characterizing quantity for our switch?
The switch does not have any characterizing quantities.
Okay. And what is the method of measuring of the switch? Does it also?
I don't think we can have a method of measurement because it doesn't have any characterizing quantity.
And how many terminals does it have? So let's see. It has one terminal right here and another terminal right here. So I think it has two terminals. Okay, the next one is our connecting wires. So this is we have multiple connecting wires right here, and you can see that there are two. For example, for this one, we have two terminals, this one and this one, and we can connect any electrical system, and we can use in our electrical systems. So what is the circuit symbol for a connecting wire?
It's a simple straight line.
And what is the characterizing quantity?
Just like switch, it doesn't have any characterizing quantity.
Does it have a method of measurement? And we have said that the number of terminals is 2, so it has 2 numbers of 2. So our next element is the voltmeter. So we have similar looking elements right here. These two look similar, but they are actually really different. The first one has a V written on it at the middle, while the other one has an A written on it. This stands for voltmeter and this stands for milliammeter. So milliampere, I'm sorry. So we are going to use this because this measures the volt. And the voltmeter actually measures the volt and has 2 terminals, and we use it in mainly electrical systems to measure a volt. So what is the circuit symbol for a voltmeter?
It's a V inside a circle with 2 lines extended out of it.
So what's the characterizing quantity for a voltmeter?
Well, as you can see here, it shows that the voltmeter has from 0 to 10, which means it can only measure from 0 voltage to 10 voltage, which means the range of the volt. And this one, the fact that there's a line underneath the V shows that it can only measure DC.
Okay. So what is the method of measurement for a voltmeter?
Well, a voltmeter is a measuring instrument, so once it's connected to a DC circuit, it starts to measure the voltage.
Okay. So we have said earlier that it has 2 terminals, so the number of terminals for a voltmeter is 2. The next one is our ammeter. We have previously described an ammeter, and an ammeter similar to a voltmeter has 2 numbers of terminals, and it also measures the current of our systems. So what is the circuit symbol for an ammeter?
It is an A inside a circle with 2 horizontal lines extended to it, just like a voltmeter but with an A.
What is the characterizing quantity for an ammeter?
Well, just like the voltmeter, this one has from 0 to 500, which means it can only measure from 0 to 500 milliampere, which means the range is the amount of current.
So what is the method of measurement for our ammeter?
When an ammeter is connected in series in a circuit, it starts to measure the current.
So what is the number of terminals? As we said previously, it has 2 terminals. So an ammeter has 2 terminals. And the next one is our multimeter. So you can see right here that we have different multimeters. Both of these are multimeters. While this one is a digital multimeter, this one is an analog multimeter. And a multimeter measures different kinds of elements, including the voltage, the resistance, and the current, and they also measure electricity of alternating current and direct current. So both of these are multimeters, and they have 2 terminals. So a multimeter has 2 terminals. So what is the circuit symbol for a multimeter?
It depends, because multimeters measure both voltage and ammeter. Where when it's in a circuit measuring the ammeter, we use a circle with an A inside. Well, when it's measuring the volts, we use a circle with a V inside it.
So what is the characterizing quantity for a multimeter?
Well, just like the others, it's the range of the current, voltage, or resistance that it's measuring.
And what is the method of measurement for a multimeter?
Well, as you have previously stated, the multimeter is used to measure voltage, current, and resistance when it's connected in a circuit.
So what is the number of terminals for a multimeter? As we said before, it has 2 terminals, so the number of terminals for a multimeter is 2. So our next element is the capacitor. We can find multiple capacitors. For example, we have 2 small ones and 2 big ones. The capacitor is an element which stores charge in our electrical systems, and we can see that it has 2 terminals. And what is the circuit symbol for a capacitor?
It's 2 parallel lines equal, and a horizontal line going through them.
And what's the characterizing quantity?
Well, it's a capacitance. It's how much energy, how much electricity it can store.
Okay. And what is the method of measurement for a capacitor?
Well, there are 2 ways to measure the capacitance. First, we can apply the formula that capacitance is equal to amount of charge over voltage, but we can also drive another formula by using the geometry of the capacitance. So capacitance becomes the electric constant times area of the plates over distance between the 2 plates.
Okay. So we have said previously that it has 2 terminals, so the number of terminals for a capacitor is 2. The next one is our inductor. The inductor is just like a resistor, but it does not dissipate energy. The inductor is a coiled wire that are used in fluorescent lamps, And what is the circuit symbol for an inductor?
Something that looks like this. It has a parallel line in between.
Okay. So what is the characterizing quantity for an inductor?
Well, it's resistance because it's also a resistor.
And what is the method of measurement of an inductor?
Well, if the characterizing quantity is the resistance, the method of measurement is just to measure the resistance.
Okay. And what is the number of terminals for an inductor? I think it is 2. And the next one is the diode. We have a diode right here, and this is a light emitting diode, and these are also diodes. And we have multiple kinds, and we can see that it has 2 numbers of terminals. So what is a circuit symbol for a diode?
Something that has a triangle and a line. The 2 other terminals coming out of them.
And what is the characterizing quantity?
There's also resistance.
And the method of measurement?
Well, diodes only allow the flow of current in one direction, so from this we can infer that it has infinite number of resistance on one side, and then it has no resistance, so it allows current to flow. So we have to measure resistance.
Okay. And we have seen that it has 2 terminals, so the number of terminals for a diode is 2. The next one is a transistor. We have 2 transistors right here. They are very small. The transistor has 3 terminals, unlike the others we have seen. And it is used in multiple kinds of electronics, including our phones and LCD TVs. Okay. So, what is the circuit symbol for a transistor?
The circuit symbol is going to be a circle with 3 lines coming and going out of them to represent the 3 terminals.
So, what is the characterizing quantity for a transistor?
Well, it has resistance because it controls the resistance.
And what is the method of measurement?
So we just measure the resistance, we measure the resistance.
And what is the number of terminals? As we have seen, it has 3 terminals. So the number of terminals for a transistor is 3. The next one is the light emitting diode. Just like we have seen previously, the light emitting diode has 2 terminals. And what's the circuit symbol for a light emitting diode?
It's like the diode with the triangle and 2 terminals coming out, but with an arrow on top.
Okay. So what is the characterizing quantity for a light emitting diode?
There's also resistance.
And the method of measurement?
We'll just measure resistance.
And the number of terminals for a light emitting diode is 2, just like it is seen right here. Okay, our next element is the rheostat. The rheostat is this one. As we can see, a rheostat is a variable resistor, and it has 1, 2, and 3 numbers of terminals, but only 2 can be used at a time. So what is the circuit symbol for a rheostat?
A rheostat is a variable resistor, so it has a symbol similar to that of resistor, but with an arrow that crosses it.
So what's the characterizing quantity for a rheostat?
Well, it's resistance because it has variable resistance. When we move it up and down like this, we can change the length, so the resistance is variable.
Okay. So what's the method of measurement for a resistor? For a rheostat?
As we have said before, a rheostat is a variable resistor, and the resistance varies because we are varying the length. So we have to write a formula that relates all these elements. So the rheostat's resistance is measured by the formula length times resistivity over area.
And we have seen previously that it has 1, 2, 3 terminals. So a rheostat has 3 terminals. And our next one is the crocodile clip. Okay, so we have one crocodile clip and another one right here. A crocodile clip is just like a connecting wire, but it has something that looks like a crocodile's mouth at both ends. So a crocodile clip is just like any connecting wire.
The circuit symbol for a crocodile clip is going to be just like the connecting wire, a simple straight line.
Okay, so what's the characterizing quantity?
Just like the wire, it doesn't have one.
Okay. Does it have a method of measurement?
No, because it doesn't have any characterizing quantity.
Okay. So what's the number of terminals? Just like we have seen, it has 2 terminals. This is the table we prepared, and in the first column there are circuit elements, in the second column there are circuit symbols, in the third column there are characterizing quantities of the circuit elements, in which most of them are resistance, and the methods of measurement of the circuit elements are in the fourth column, and the last column shows the number of terminals of these circuit elements, in which most of them are 2. That's it.
The point of this activity is to create a current tester, and the instruments we're going to need is a dry cell. We also need a compass, a switch, a light bulb, and a voltmeter. So first we're going to check if the dry cell is active and if it has any voltage in it. As you can see, it has about 3 volts, which because each dry cell has 1.5 volts. So
The next activity is going to be constructing the current tester. We are going to put the materials in place.
Constructing a galvanoscope is quite easy. Well, as you can see, first we connect the dry cell directly to the switch, and we also connect it to the light bulb, and we also connect the light bulb to the switch. And we can turn it off like this. So we take our compass and we wrap a wire around it. Sure. Okay. So we should make this a part of the circuit. Well, I've connected these wires to the switch and this one to the light bulb, so when I light it like this, you can see that this deflects a little.
The bulb lights up because there is current in the wire, but what's the point of a tester in this system?
Archie is right. We know that there's current because the bulb lights, but I don't get why the compass and coil are added.
Okay, so when there's no current flowing in the circuit, as you can see, the compass rests in the usual north-south direction. However, when there's current, the needles of the compass deflect. So from this we can infer that it's used to determine the direction of the current.
How?
Well, first look at the direction of the deflection. And now I'm going to reverse the direction of current by interchanging the position of the contact points between the two terminals. And now we're going to light the bulb, and as you can see, the direction of the deflection is changed.
Yes. First, the deflection was to the top of the magnet, but now the deflection has changed. So this means that the tester we have created also measures the direction of the current.
I'm a little convinced that the galvanoscope is better than an indicating light, because an indicating light is the same even when the direction of the current is changed. Now we can ask one other question.
What's the question?
We have determined that we can know the current flow, the direction of the current, but can we know the current flow, the amount of the current flow using this tester?
To see the different deflection points of the compass previously, we have reversed the connection points. So to see the current flow in the circuit, why don't we change the battery and use a more powerful battery and see the deflection? So here we have two dry cells, each with 1.5 volts. So we can check that first. We can see that it has 3 volts, so we can use this. So using this battery, when we connect it with the rest of the circuit, first we can connect only one of them by using this wire, and while doing that, we can see that the bulb lights up very slightly, and we can see also a small deflection on the compass. We can see a small light on the light bulb and a really small deflection. And a really small deflection on the magnet, as we can see right here. So by using the second wire, we can use 3 volts by using both of the dry cells. And we can see that the deflection is really big, because we have used a really strong dry cell, and the current in the cell also increases. So we can see that the galvanometer also measures the current in the cell.
This is a simple and useful device. It can be used to determine the presence of a current and its direction as well. It also gives some information about the amount of current in the form of deflection and angle deflection.
But don't forget to use it on the mains.
That's correct. The tester only gives the estimate of the current flow, but there are devices that measures not only the flow of the current, but also the voltage. we will do that activity in the future.
So we're done for today.
Yes.